Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for February 13th of 2025 is titled Reflections on VdB 31. So what do we see here? Well, here we see the reflection nebula known as VdB 31, which is based on the catalog done in the mid 1960s by astronomer Sidney Vandenberg. And what this astronomer cataloged was reflection nebulae. Now, reflection nebulae occur when there is dust around a very hot star, typically. And what happens is the light from that star gets scattered off of the dust grains. And the dust grains are really good at scattering short wavelengths of light, not so good at scattering the longer wavelengths. That means the blue light gets scattered well, and the red light pretty much passes through the dust. And that's what we see here. We see all that blue coloring of the dust because it is the blue light that has been scattered much better than the red light from the star. Now, in addition, that star is also emitting a lot more blue light, which also helps. Because it is a very hot star, hot stars tend to emit shorter wavelengths primarily, and therefore will look blue when we look at them in the sky. Now, that's the example of the reflection nebula, but we can also see the dark nebulae around it. Those dark dusty blotches off to the left and below the reflection nebula are what we call dark nebulae. Now, the dark nebulae are also dust. What is the difference then? Well, in the dark nebula, the dust is denser. It's still pretty much a vacuum as we see it here from Earth. But it is denser and there is enough material there so that no matter where you look through those dust clouds, your line of sight will hit a dust grain at some point before you get out of it. So you will not be able to see through the dust cloud because it becomes opaque. It blocks out all the light from behind us. So what we look at when we see this, there are stars behind those dust clouds that we don't know about, and we have no way of seeing, simply because they happen to be positioned in the wrong spot. So there are just as many stars behind those dust clouds as there are in other parts of the image. Simply those areas we cannot see them. Now, you can also, if you look around the edges of those dust clouds and through some of the fainter dust where we can see stars, you tend to notice that the stars look red. That's because the dust not only blocks out light, but it preferentially blocks out the blue light. Now, we've seen that in the scattering. It's very good at scattering the blue light and seeing it come from all directions. And the red light tends to pass straight through. And that gives us the coloring there. So dust does two things when it's present. It blocks out light, or at least makes stars look fainter if it's not dense enough to completely block out the light, as in the denser clouds here. But it also makes them look redder than they otherwise would be. So some of those stars that look quite red that are close to those dust patches may in reality not be red stars. We simply change the color because all of the shorter wavelengths, the blue light, has been scattered out of them. So that was our picture of the day for February 13th of 2025. It was titled Reflections on VdB 31. We'll be back again tomorrow for the next picture, previewed to be when roses are red. So we'll see what that is about tomorrow. And until then, have a great day, everyone. And I will see you in class.